Hello students and welcome to the channel SNW Physics classes. If you really understand the concepts taught here, please turn the black thumb blue. That means like the video, share with your friends and subscribe to the channel SNW Physics classes. For the latest update, do not forget to hit the bell icon. This is the second part of the chapter, first class 10th physics, that is light, reflection and refraction. In this video, we are going to deal the topics rules for image formation by spherical mirror, ray diagram for spherical mirrors, new Cartesian sign convention, mirror formula, and some numerical based on mirror formula. So the very first topic is rules for obtaining images formed by spherical mirrors. So the rule first is a ray of light which is parallel to the principal axis of a spherical mirror, okay, a ray of light which passes parallel to the principal axis of a spherical mirror. Let me draw a ray of light which is passing parallel to the principal axis of a spherical mirror. What it happens? Then it happens that it passes through the focus. It passes through the focus. A ray of light coming from the infinity. This is the ray of light which is coming from infinity. After reflection, it passes through the focus. After reflection, it passes through the focus. So here it is the center of curvature of the mirror and this is the focus. What the first rule is telling us that when a ray of light comes from infinity, अगर कोई ray of light infinity से आ रही है and that is parallel to the principal axis, this one is the principal axis. We have discussed the terms related to spherical mirror. In previous video we have discussed it. Please go on the I button to look after the previous video, understand this topic, what is center of curvature, focus, principal axis, pole, and every terms related to spherical mirror. This one is the pole, this is center of curvature C, F is the focus. Then what the rule is saying, a ray of light which is parallel to the principal axis of a spherical mirror, it passes through its focus, this focus, after reflection from the mirror. Okay, the ray of light which is coming from infinity, this is the ray of light which is coming from infinity or parallel to the principal axis. Then what happens? The first rule says that it passes through the focus after reflection. Now let us see the same case for the convex mirror. This one was concave mirror. So in the case of convex mirror, again when the ray of light coming from infinity and parallel to principal axis, after reflection it passes through the focus. It passes through the focus. As I previously mentioned that it is a diverging mirror and the light really do not passes through the focus. It seems to be passing or it appears to be passing like this. So we will draw a dotted line here so that we can show that it is passing through the focus. It is appearing to be passing from the focus. Okay. So in the case of concave mirror we have saw it here, and in the case of convex mirror also we saw here. So the ray of light which is parallel to the principal axis of a spherical mirror, why I have mentioned here a spherical mirror, because we have both the mirror to consider here. यहाँ हम लोगों ने दोनों mirror को एक साथ देख लिया है. In the case of concave also we saw that the ray of light parallel to the principal axis passes through the focus after reflection. ठीक है, जो ray of light principal axis के parallel आ रही है, after reflection it passes through the focus. Here also it is the same condition. It passes through the focus after reflection. Okay, after reflection it passes through the focus. Next rule says that a ray of light passing through a center of curvature, of a spherical mirror is reflected back along the same path. क्या कह रहा है? If a ray of light is passing through the C, center of curvature, passing through the C, here also we will see it is F and it is C. If a ray of light is passing through the center of curvature, then it is sent back in the same direction. It is sent back in the same direction. Here we can see here, if the light goes here through center of curvature, then after reflection, it is sent back on the same path, along the same path. Similarly, we can see in the case of convex mirror. That if a ray of light is passing through the center of curvature, then it is sent back on the same path, along the same path after reflection. So the rule second is a ray of light passing through the center of curvature of a spherical mirror, it is reflected back along the same path. Now, the rule third is a ray of light passing through the focus. It is just opposite of the first rule. ठीक है? First rule के opposite है. उसमें क्या हो रहा था कि parallel ray was coming and it was falling on the focus after reflection. But इसमें क्या है कि focus से light rays जो है वो pass हो रहे हैं और after reflection it becomes parallel to the principal axis. After reflection it becomes parallel to the principal axis. How? Let us see here. Let it be C again and ये हमारा हो गया focus. Also here we will draw. It is focus and it is the center of curvature. What happens here is it is the just opposite of first rule. ये opposite है बिल्कुल first rule के. The ray of light when crosses through or passes through the principal focus, then it is sent parallel to the principal axis after reflection. Okay? ये क्या हो रहा है? Ray of light जब principal focus से होकर के cross करेगी या pass करेगी, then it will be sent back or it will be reflected parallel to the principal axis. Same here in the case of convex mirror. In the case of convex mirror, we will see that when a ray of light falls on the principal axis, it is directly not falling, it seems to be falling on the principal focus. Okay, when a ray of light falls on the principal focus as it appears to be falling on the principal focus. Okay, then after reflection it goes parallel to the principal axis. After reflection it goes parallel to the principal axis. Okay, here is the path. Ray of light is falling on the principal focus. After reflection it goes parallel to the principal axis. We have understood the third rule, that the ray of light passing through the principal focus of a spherical mirror, it becomes parallel to the principal axis after reflection. Okay, after reflection it becomes parallel to the principal axis. ठीक है, फोकस पे अगर कोई रे ऑफ लाइट पास कर रही है तो रिफ्लेक्शन के बाद क्या होगा? अकॉर्डिंग टू थर्ड रूल, इट विल गो पैरेलल टू द प्रिंसिपल एक्सिस. इट विल गो पैरेलल टू द प्रिंसिपल एक्सिस. Here we have the fourth rule. Here we have the fourth rule, and the rule is a ray of light which is incident at the pole of a spherical mirror. अगर कोई ray of light जो है वो pole पे fall करे, okay? Let me again make here. It is C, it is F, means principal focus. Again here we have principal focus of convex mirror, and it is the center of curvature for convex mirror. Now what is the fourth rule saying is, when a ray of light falls on the pole, okay, it is the pole, center of the mirror, okay, center of the spherical mirror is known as pole. It is the pole of concave mirror, and this one is the pole of convex mirror, okay. So the fourth rule is saying that a ray of light which is incident on the pole of a spherical mirror, then it is reflected back by making the same angle with the principal axis. Do you remember the second law of reflection? That angle I is equal to angle R. So it follows the second law of reflection, and it is reflected back by making the same angle. It means this one is angle I and this one is angle R. This one is angle R. Okay. So it follows the second law of reflection, and it is sent back by making the same angle with the principal axis. Okay. The ray of light which is incident at the pole of the spherical mirror is reflected back, making the same angle to the principal axis. Again, we can see here in the case of convex mirror, it happens the same. When a ray of light is incident on the pole, then it is sent back by making the same angle. Same angle means it is the angle of incident, and it is the angle of reflection. It is the angle of reflection. Okay. It is the incident ray and it is the reflected ray. Okay. After knowing all the rules of image formation by spherical mirror, we will consider how we can form images on spherical mirrors. Very first, the first type of mirror is concave mirror, and we will see all the images formed by concave mirror. बिकॉज इसमें होता क्या है कि अलग अलग पोजीशन पे अगर हम ऑब्जेक्ट को डिफरेंट डिफरेंट जगह पे रखें तो इमेजेस जो फॉर्म होगी इट विल बी डिफरेंट. ओके, अलग अलग जगह पे अलग अलग तरह की इमेज फॉर्म होती है. एंड लाइकवाइज वी हैव 6 केसेस. इस तरह से हम लोगों को 6 केसेस मिलते हैं कॉन्केव मिरर में. सो द वेरी फर्स्ट केस इज व्हेन द ऑब्जेक्ट इज प्लेस्ड बिटवीन पोल एंड प्रिंसिपल फोकस. ठीक है, जब हम ऑब्जेक्ट को पोल और प्रिंसिपल फोकस के बीच में रखेंगे. लेट मी राइट हियर, इट इज C, center of curvature, this one is F, principal focus, and this is the pole, the center of the mirror. Okay, so the first case is when object is placed in between pole and प्रिंसिपल फोकस. सबसे पहले हम लोग देखेंगे कि ऑब्जेक्ट जो है वो कहाँ रख रहे हैं हम लोग, पोल और प्रिंसिपल फोकस. दिस वन इज प्रिंसिपल, this one is pole and this is principal focus. Okay, now very first rule was when a ray of light passes parallel to principal axis. Principal axis, ये हमारी principal axis है और दिस वन इज प्रिंसिपल एक्सिस. और जब कोई रे ऑफ लाइट जो है प्रिंसिपल एक्सिस के पैरेलल पास करती है, देन आफ्टर रिफ्लेक्शन इट पासेस थ्रू द फोकस. आफ्टर रिफ्लेक्शन इट पासेस थ्रू द फोकस. ठीक है, रिफ्लेक्शन के बाद ये कहाँ जाएगी, फोकस पे पास करेगी. दिस वाज द फर्स्ट रूल. वी नो दैट फॉर द फॉर्मेशन ऑफ इमेज वी नीड at least 2 rays. ठीक है, what is image? The point where 2 or more than 2 rays meets each other. ठीक है, तो यहाँ पे जो हमारा सेकेंड रूल होगा, if the ray of light is passing through the center of curvature. सेकेंड रूल, बिकॉज हम लोगों को एक और यहाँ पे रे को फॉल कराना है या पास कराना है. सो second rule is if ray of light passes through the center of curvature. Okay, if ray of light passes through the center of curvature, ठीक है, then what happens? It is sent back along the same direction. It is sent back along the same direction according to second rule of image formation. ठीक है, रे ऑफ लाइट जब सेंटर ऑफ कर्वेचर पे जाती है तो फिर वापस उसी डायरेक्शन में, उसी पाथ पे वो वापस आ जाती है. इन दिस वे हियर वी कैन नॉट इंटरसेक्ट दीज टू रेज. यहाँ पे हम दोनों रेज को मीट नहीं करा सकते हैं बिकॉज ये डाइवर्ज हो रहे हैं एक दूसरे से. सो इंटरसेक्टिंग पॉइंट विल बी बियॉन्ड द मिरर. मिरर के पीछे हम लोगों को क्या मिलेगा? इंटरसेक्टिंग पॉइंट, जहाँ पे दोनों रेज जो है आपस में इंटरसेक्ट करे. Okay, let us see where it is intersecting. Please use scale while drawing these lines because light always travels in a straight line, and if you will show a curved line or a non-straight line, then your marks may be deduced. Okay, now so these two rays meets here. ये दोनों rays जो है वो कहाँ meet कर रही है? इस पॉइंट पे, इस पर्टिकुलर पॉइंट पे. सो द इमेज ऑफ दिस ऑब्जेक्ट, 1 मिनट, द इमेज ऑफ दिस ऑब्जेक्ट विल बी हियर. यहाँ हम लोगों को ये ऑब्जेक्ट की जो है वो इमेज मिलेगी. ओके, तो ये मेरा क्या हो गया? लेट इट बी ए एंड दिस वन बी बी, पॉइंट बी. ठीक है, now the image is A dash and B dash. तो हम लोगों को इस फर्स्ट केस में क्या मिला? Let us see the nature of image. It is virtual and erect. Erect means सीधा, ऑब्जेक्ट सीधा है, and it is virtual. ठीक है, it is beyond the mirror. Next nature is it is behind the mirror and it is magnified. It is larger than the object. ऑब्जेक्ट से ये बड़ा है. ठीक है, तो ये जो इमेज हम लोगों को मिला, इट इज लार्जर देन द ऑब्जेक्ट. इज इट लार्जर देन द ऑब्जेक्ट? तो हमें इस केस में जो हमें नेचर ऑफ इमेज मिला, दैट इज वर्चुअल एंड इरेक्ट, बिहाइंड द मिरर एंड लार्जर देन द ऑब्जेक्ट. दिस इज द रे डायग्राम फॉर द फर्स्ट केस ऑफ इमेज फॉर्मेशन इन कॉन्केव मिरर. ठीक है, ये रे डायग्राम है किस लिए? हमारे फर्स्ट केस के लिए. The next case for image formation in concave mirror is, that is case 2, when the object is placed at the focus of concave mirror. जब ऑब्जेक्ट जो है वो फोकस पे हम लोग रखेंगे तो उस केस में कैसी इमेज बनेगी? लेट अस सी इट. लेट इट बी सी अगेन, F and P. Okay, so we will again apply the first rule of image formation. It means if a ray of light goes parallel to the principal axis, then after reflection it is passing through the प्रिंसिपल फोकस. फर्स्ट रूल यही कहा है हमारा. फर्स्ट रूल जो है वो इमेज फॉर्मेशन का यही बोलता है कि अगर कोई रे जो है वो प्रिंसिपल एक्सिस के पैरेलल जा रही है, देन आफ्टर रिफ्लेक्शन इट विल पास थ्रू द प्रिंसिपल फोकस. ठीक है, मैक्सिमम जो है केसेस जो है हमारे 2 रूल से बन जाते हैं, लेकिन फिर कुछ स्पेशल केसेस होते हैं जिसमें हम लोगों को थर्ड रूल या फोर्थ रूल को भी यूज करना पड़ता है. सेकेंड रूल इज, इफ the ray of light passes through the center of curvature, then it is sent back in the same direction. It is sent back in the same direction. ठीक है, सेंटर ऑफ कर्वेचर है, इस पे राइट ऑफ रे ऑफ लाइट गया और फिर उसके बाद वापस उसी डायरेक्शन में वापस आ गया. ओके, हियर व्हाट वी सी, द लाइंस आर पैरेलल टू ईच अदर. यहाँ पे जो लाइन है, दे आर पैरेलल टू ईच अदर. It means we have to put a screen here. ठीक है, यहाँ पे दोनों रेज को मीट कराने के लिए हम लोगों को क्या यहाँ पे करना होगा, वी हैव टू पुट स्क्रीन हियर, और उस स्क्रीन पे जो है इमेज फॉर्मेशन होगा, ठीक है। इन दिस केस, इन सेकेंड केस, वी हैव टू पुट वन स्क्रीन हियर, जस्ट लाइक प्रोजेक्टर। प्रोजेक्टर में हम लोग स्क्रीन रखते हैं, जो रिफ्लेक्टेड लाइट है उसके इमेज के फॉर्मेशन के लिए हम लोग स्क्रीन रखते हैं, ओके। तो इन दिस केस व्हेन ऑब्जेक्ट इज प्लेस्ड ऑन प्रिंसिपल फोकस, ऑब्जेक्ट को हम लोगों ने प्रिंसिपल फोकस पे रखा है, उस केस में वी हैव टू पुट वन स्क्रीन हियर फॉर द इमेज फॉर्मेशन, ओके। नाउ we will see what is the nature of the image formed in this case. In this case, the image will form on infinity. ठीक है, infinite distance पे image होगी. As we know that जो images जो होते हैं मिरर के सामने फॉर्म करते हैं. पिछले केस में हम लोगों ने देखा था इमेज वॉज फॉर्म बियॉन्ड द मिरर दिस साइड, ओके, इस साइड इमेज को फॉर्मेशन हुआ था. तो उस केस में क्या था, द इमेज वॉज वर्चुअल, द इमेज वॉज वर्चुअल. But in case the image is formed in front of the mirror, then we will have real and inverted image. Then we will have real and inverted image, and the image will be highly magnified. ठीक है, image will be highly magnified. प्रोजेक्टर में हम लोग एडजस्ट करते हैं ना, the image formed is magnified, और उस मैग्निफिकेशन को हम लोग एडजस्ट करते हैं अपनी स्क्रीन के अकॉर्डिंग. Okay. Now we have the third case for image formation in concave mirror. When the object is placed in between focus and center of curvature. Object कहाँ पे है यहाँ पे? Focus और center of curvature के बीच में. Let me write here C, F and P. Okay. So the first rule was when a ray of light goes parallel to principal axis, it passes through the principal focus. ठीक है, पहला रूल हमारा ये था कि कोई रे ऑफ लाइट जो है अगर प्रिंसिपल एक्सिस के पैरेलल है तो क्या होगा, आफ्टर रिफ्लेक्शन इट विल पास थ्रू द फोकस. आफ्टर रिफ्लेक्शन इट विल पास थ्रू द फोकस. Next rule was when a ray of light passes through the center of curvature, when a ray of light passes through the center of curvature, it is sent back in the same direction. It is sent back in the same direction along the same path. In this case, we get a real and inverted image here. A real and inverted image. Okay, let me draw one line, extend this line. I will extend this line. We will get a real and inverted image here on the principal axis. ठीक है, यहाँ पे हम लोगों को एक inverted image मिली beyond the center of curvature. ठीक है, सेंटर ऑफ कर्वेचर के पीछे हम लोगों को वो इमेज मिली. कहाँ पे मिली वो, सेंटर ऑफ कर्वेचर के पीछे. इसे रेड कर देते हैं, अदरवाइज यू विल बी कंफ्यूज व्हिच इज इमेज एंड व्हिच इज ऑब्जेक्ट. So here we get the image. So let us see what is the nature of image we form here. Let it be A and this one be point B. So we get the images B dash, it is inverted. So B will be upside and A will be downward. ठीक है. So the nature of image formed will be beyond the center of curvature, means center of curvature के पीछे जो image मिला हम लोगों को, that is beyond the center of curvature. Real and inverted. Inverted means ulta. Okay, real and inverted, and obviously it is larger than the object. इट इज लार्जर देन द ऑब्जेक्ट. ऑब्जेक्ट की साइज हम लोग देख सकते हैं यहाँ पे, एंड इमेज हाइट इज this one. So it is larger than the object. Now we have the fourth case when the object is placed at the center of curvature of a concave mirror. ठीक है, हम लोग अब केस देखेंगे, that is fourth case when the object is placed at the center of curvature of a concave mirror. Let me write here again. It is C and the object is placed on center of curvature, that is C. C पे ही हमारा object है. It is F and this is P. Now in this case, we will get the image like this. Let us follow again the same rule. हम लोग rules को follow करेंगे जिस तरह से हम लोग पहले रूल्स को फॉलो कर रहे थे, बट हियर वी हैव टू ऐड इज द थर्ड रूल. अब तक हमारा जो इमेज था वो दो रूल से बन जा रहा था, रूल फर्स्ट और रूल सेकंड से बन जा रहा था, बट नाउ वी विल हैव टू यूज द थर्ड रूल दैट इज, लेट अस सी, फर्स्ट अकॉर्डिंग टू फर्स्ट रूल यहाँ पे हम लोगों ने फिर वही कर लिया. व्हेन द रे ऑफ लाइट passes parallel to the principal axis, it is sent on the principal focus or it passes through the principal focus after reflection. यहाँ पे रे जो है इस पे फॉल किया, it is incident ray, and after reflection it passes through the principal focus. But here we have to use the third rule, that is when the ray of light passes through the principal focus, then after reflection it is sent on parallel to the principal axis. Sent parallel to the principal axis. ये रहा हमारा रे, इधर से जा रहा है, that is on focus. ये पास कर रहा है फोकस से. After reflection, it goes parallel to the principal axis. So the image we get is let me change the color of image so that see जो है हम लोगों को आसानी से दिख जाए. So the image is on the center of curvature. ये ऑब्जेक्ट के ठीक नीचे ये हमारा इमेज का फॉर्मेशन हो गया. लेट इट बी ए, ओके, लेट इट बी ए, and this one is B, and image form will be B dash, and this is A dash. Okay, now the nature of image formed is at the center of curvature, यानी जो image हम लोगों को मिला, that is exactly on the center of curvature, that is exactly on the center of curvature, that is C. ये कहाँ पे है? हमारा C के ऊपर है. Next is real and inverted. Yes, obviously it is real and inverted क्योंकि ये image जो है वो mirror के front में form हुआ है. Okay, and the third जो हमारा nature है, that is exactly the same size of the object. Object के size के ये बराबर है. ठीक है? It is the fourth case when the object is placed at the center of curvature. Now, the fifth case is when the object is placed beyond the center of curvature of the concave mirror. ठीक है? Beyond the center of curvature means center of curvature के पीछे. Again we have the object A, B. AB is the object. Here it is C, center of curvature. Here it is F, and this one is P. ठीक है? अब हम लोगों ने ऑब्जेक्ट को कहाँ रखा है? Beyond the center of curvature. Again we will follow the same rule, that is when the ray of light goes parallel to the principal axis, it is passing through the focus after reflection. After reflection, it is passing through the focus. ठीक है? पहला रूल हमारा यही बोलता है कि हम लोगों को क्या करना है? एक रे ऑफ लाइट लेना है जो कि पैरेलल हो प्रिंसिपल एक्सिस के, एंड आफ्टर रिफ्लेक्शन इट विल पास थ्रू द फोकस. Now again we have the second rule, that is when a ray of light passes through the center of curvature, it is sent back on the same direction. ठीक है, ये कहाँ जाता है फिर वापस उसी डायरेक्शन में जाता है. So we have the intersection here. यहाँ पे हम लोगों को एक intersecting line मिला and the image will be formed exactly here. ठीक है, इमेज हम लोगों का यहाँ पे हम लोगों को मिल गया. Again we will write here B dash because it is real and inverted image. ठीक है, B dash and this side it is, this point will be A dash. So the nature of image formed is between pole and center of curvature. Image कहाँ पे form हुआ? That is position of the image is between pole and center of curvature. Sorry, between focus and center of curvature. And the image is real and inverted क्योंकि ये front of the mirror में बना. Okay, image is real and inverted and it is smaller than the object. Object से ये छोटे size में बना है. Okay. The sixth case is when the object is at infinity. Infinity means it is infinite distance. Object जो है वो visible भी हो सकता है, non visible भी हो सकता है. Okay. So जब infinity से आ रही है, ठीक है, तो do you remember what is the definition of principal focus? When the rays coming from infinity goes parallel to principal axis, then what happens? It passes through the principal focus. तो इस केस में क्या होगा कि जो ऑब्जेक्ट होगी वो कहाँ पे फॉर्म करेगी? That will form on principal focus. That will form on principal focus just like this. यहाँ पे भी हम लोगों ने ड्रॉ कर लिया. तो इस केस में जब जो रे ऑफ लाइट जो है वो इनफाइनाइट डिस्टेंस से आ रही है, तो उस केस में क्या होगा? इमेज विल बी फॉर्म्ड ऑन प्रिंसिपल फोकस. ठीक है, इमेज विल बी वेरी डिमिनिश्ड मीन्स बहुत छोटा होगा. ठीक है, द इमेज फॉर्म विल बी हियर, इट इज वेरी स्मॉल, मच स्मॉलर देन द ऑब्जेक्ट. अगर आप लोग को याद होगा, हम लोग सन की इमेजेस को बनाते थे वो लेंस लेकर के. ठीक है, लेंस लेकर के अगर हम लोगों ने सन की इमेज को बनाई तो सारी रेज जो है वो एक जगह पॉइंट आउट होकर के, और अगर हम लोग बचपन में खेले थे तो याद होगा कि क्या होता था कि किसी पेपर में या फिर किसी कॉटन बॉल में हम लोग उसको सारे रेज को एक जगह कलेक्ट करके और उसमें हम लोग फायर इग्निट कर देते थे, आग जला देते थे. ओके, तो इस तरह के केसेस जो होते हैं वो यहाँ कॉनकेव मिरर में होता है. अभी लेंस भी हम लोग पढ़ेंगे तो उसमें भी देखेंगे. ये जो है हमारे केस होते हैं फॉर द इमेज फॉर्मेशन. ओके, नेचर ऑफ इमेज फॉर्म्ड इज एट प्रिंसिपल फोकस. कहाँ पे इमेज बन रहा है? ऑन प्रिंसिपल फोकस, एंड इट इज रियल एंड इन्वर्टेड एंड इट इज मच स्मॉलर, डिमिनिश्ड. ठीक है, बहुत बहुत छोटा बनेगा ऑब्जेक्ट के. दिस इज द लास्ट केस फॉर द concave mirror. Now for the image formation, so the second one is convex mirror. Now we will see how we can form image on convex mirror using the rules of image formation in spherical mirrors. Okay, the first case is when the object is placed anywhere between pole and infinity. In convex mirror we have only two cases. Okay, in convex mirror we have only two cases. Means if the object is placed at finite distance, means the distance we are knowing, and the second case is when the object is placed at infinite distance. ठीक है, यहाँ पे हम लोगों ने देखा कि object is placed between pole and infinity. infinity और pole के बीच में हम लोगों ने object को रखा. let it be a भी एक ऑब्जेक्ट है जो किसी कॉन्वेक्स मिरर के फ्रंट में रखा हुआ है बिटवीन पोल एंड इंफिनिटी. कॉन्वेक्स मिरर है, फोकस विल बी दिस साइड एंड दिस इज द center of curvature. Okay. Now let us see what is the rule saying. Rule is saying that when the rays goes parallel to the principal axis, then after reflection, it will be appear to go or pass through the principal focus. Use scale because this time I'm not having the scale. Okay. It will pass through the, or it will seems to be passing through the principal focus. ठीक है? First rule हमारा ये बोलता है it will pass through the, or it will appears to be passing via principal focus. Okay. इसे हम rays को indicate कर देते हैं arrow को दे करके. It is falling and it is reflecting back. Now second rule is saying that when ray of light passes through the center of curvature, then it is sent back in the same direction. Then it is sent back along the same path from the center of curvature. Okay, the rays are passing along the same path of center of curvature. Okay, so the rays meets here. यहाँ पे रे का जो होता है वो intersection हो रहा है. So the image formed will be here. Image formed will be here between pole and focus. Between pole and focus, the image will be formed. Always remember that a convex mirror always makes a virtual and erect image. Also, it makes diminish, means the image is smaller than the object. Okay, that's why it is used in the rear view of the vehicles. Okay, so we get the nature of image behind the mirror, means mirror के जो है पीछे बना है object. Between pole and principal focus, object is image is formed between pole and principal focus. Second one is virtual and erect, and third one it is diminished, means smaller than the object. It is smaller than the object. Now we have the second case of image formation in convex mirror. Okay. The second case is when the object is placed at infinity, means the distance is infinite. We don't know the distance. Let it be P, that is pole, principal focus, and C. Again, we will see the same rule, or we can say the definition we have remembered on the of the principal focus, that when the ray of light coming parallel to the principal axis from infinity, it passes through the principal focus. It passes through the principal focus after reflection, or it appears to be passing from principal focus after reflection. Give a minute. Let it be of green color. Let me change the color here so that you can find out which ray is actually passing and which ray is appearing to be passing. So here it is, the green color, which shows that the ray is not actually passing, it is appearing. It appears to be passing via focus. Okay. Similarly, here also, this ray is actually reflecting back because a convex mirror is a diverging mirror. And this side also we will do it the same. In this case, the image will be formed on the principal focus. Image जो है कहाँ बनेगा हमारा? Principal focus के ऊपर ही बनेगा. Okay, and it will be very small, highly diminished. ठीक है, maybe point size image. Okay, so the ray is coming in this way. Okay, the ray is coming in this way and it is reflected like this. Okay, let me draw the arrow so that it will be easily recognized that which direction is incident ray and which is reflected ray. Okay, so now we will see the nature of image formed. The nature of image form is behind the mirror, at focus. Okay, it is behind the mirror, mirror के पीछे बना, at focus. It is virtual and erect and it is highly diminished. पहले ही हमने बताया था कि जो हमारा convex mirror है, it always forms virtual and erect image. So far we have seen different cases of image formation in concave mirror. It is a summary of the image formation by concave mirror. So the first case is within the focus, between pole and principal focus, the position of the image is behind the mirror, it is enlarged and the image is virtual and erect. It is the only case where a concave mirror forms a virtual and erect image. Next one is at focus. When we place the object at focus, the image is formed at infinity and it is highly enlarged. Also, the nature of image is real and inverted. Okay, between principal focus and center of curvature, the image position is beyond C. The size of image is enlarged and the nature is real and inverted. When we place the object on center of curvature, the image is formed exactly on the center of curvature equal to the object and it is real and inverted. Again, the fifth case is beyond the center of curvature, the image formed is between principal focus and center of curvature and it is diminished. Also, the nature of image is real and inverted. At infinity, when the object is placed at infinite distance, then its image is formed on principal focus and it is highly diminished, very small, and the nature of the image is real and inverted. Now, the next topic is sign convention for spherical mirrors. Sign convention means which distance must be considered positive, which is negative distance, because while measuring focal length, object distance, image distance, object height and image height, we have to consider all these things. So let us see in shortcut that how we will remember the sign convention for spherical mirrors. Okay, it is the direction of incident light. ये जो direction है ये incident light की direction है, means light is coming from this side. So all the left side distance, okay, left hand side distance pole है, all the distance is measured from pole. सारे distance को हम लोग pole से ही measure करते हैं. So the distance from leftward of the pole, ठीक है, pole के leftward distance को हम लोगों ने negative consider करना है. And right side distance is considered to be positive. The distance upward the principal axis, ठीक है, principal axis के ऊपर के distance को हम लोगों ने positive consider करना है. And the distance below the principal axis, the distance below the principal axis is considered to be negative. Okay, here we have some sign and symbols. So object distance is abbreviated as U, image distance V, focal length small f, object height h and suffix में हम लोगों ने o लगाना है, and image height is hi. Okay, ho, hi, u, v, f. These all are the symbols to be used further. Now we will see the rules under न्यू कार्टेशियन साइन कन्वेंशन. ठीक है, अभी हम लोगों ने इसे शॉर्टकट में समझा था, अभी से हम लोग क्या करेंगे, डिटेल में इसे रिटन फॉर्म में समझेंगे. ओके, ऑल द डिस्टेंस आर मेजर्ड फ्रॉम पोल ऑफ द मिरर. जितने भी डिस्टेंस होते हैं वो पोल से ही हम लोग मेजर करते हैं एज अ ओरिजिन। पोल को हम लोग ओरिजिन पॉइंट मानते हैं और सारे डिस्टेंसेस को वहीं से हम लोग मेजर करते हैं। Distance measured in the same direction as that of incident light is taken positive। अभी हम लोगों ने इस चीज को देखा था कि जो डिस्टेंस जो है वो लाइट के डायरेक्शन में अगर आ रही है दैट इज पॉजिटिव। ठीक है, इंसिडेंट रेज के डायरेक्शन में जो डिस्टेंस हम लोगों ने मेजर करना है दैट इज पॉजिटिव। द डिस्टेंस मेजर्ड अगेंस्ट द डायरेक्शन ऑफ इंसिडेंट लाइट। ठीक है, अगर उसके ऑपोजिट डायरेक्शन में कंसीडर करना है then it is negative. The distance measured upward the distance measured upward and perpendicular to the principal axis are taken as positive। ठीक है, जो distance होता है upward और principal axis के perpendicular रहे that is positive, and distance measured downward and perpendicular to the principal axis is taken as negative। ठीक है, डाउनवर्ड हो, अभी हम लोगों ने बताया है कि राइट साइड डिस्टेंस को हम लोग पॉजिटिव लेते हैं, लेफ्टवर्ड डिस्टेंस को हम लोग नेगेटिव लेते हैं, अपवर्ड डिस्टेंस पॉजिटिव एंड डाउनवर्ड डिस्टेंस इज नेगेटिव। नाउ वी हैव मिरर फॉर्मूला। ठीक है, इट इज वेरी इंपॉर्टेंट फॉर्मूला। सारे न्यूमेरिकल्स जो होते हैं मैक्सिमम इसी से पूछे जाते हैं आपको एग्जाम्स में। Mirror formula. It is a formula which keeps the relation between image distance, object distance and focal length of the spherical mirror. ये formula क्या करता है हम लोगों को image distance, object distance और focal length के बीच के relation को हम लोगों को दिखाता है। According to this formula, we have 1 by image distance plus 1 by object distance is equal to 1 by focal length. 1 by V plus 1 by U is equal to 1 by F. Here V is image distance, or we can say distance of image from the mirror. U is distance of object from the mirror, and F is the focal length, means the length between the pole and principal focus. ठीक है, linear magnification. It is also one of the important topic of class 10th. Linear magnification. The ratio of height of image to the height of object is known as linear magnification. ठीक है, it is a ratio, so it does not have any unit. ठीक है, मैग्निफिकेशन की कोई यूनिट नहीं होती है। इट इज द रेशियो ऑफ सेम क्वांटिटीज, दोनों में हम लोगों ने हाइट ही निकालना है, दैट्स व्हाई इट डज नॉट हैव एनी यूनिट। ऐसा यूनिट इसमें नहीं होती है। या फिर हम लोग दो तरह से इसको डिफाइन कर सकते हैं, द रेशियो ऑफ इमेज डिस्टेंस टू द ऑब्जेक्ट डिस्टेंस विथ माइनस साइन। ओके, in the case if we find out the ratio of object distance and image distance, then we have to put here the minus sign. Let us see mathematical expression of it. Okay, magnification is equal to height of image by the height of object, also image distance by object distance with a negative sign. यहाँ पे हम लोगों ने negative sign लगाना है. So expression is m is equal to, because linear magnification is represented by small m, so m is equal to height of image by height of object. Also we have minus v by u. Here m is the magnification, as I told you that it is represented by small m. Linear magnification is represented by small m. So hi is height of image, ho is height of object, v is the image distance, and u is the object distance. So here we have few points for linear magnification, that is if magnification has plus sign. ठीक है, अगर आंसर में हम लोगों ने मैग्निफिकेशन का प्लस साइन आया है तो द इमेज इज वर्चुअल एंड इरेक्ट, तो उस केस में इमेज कैसी बनेगी, वर्चुअल एंड इरेक्ट। इफ द मैग्निफिकेशन हैज माइनस साइन देन द इमेज इज रियल एंड इन्वर्टेड। अभी क्वेश्चन जब हम लोग डील करेंगे तो इसे और अच्छी तरह से समझ पाएंगे। ओके, द फोकल लेंथ ऑफ द कॉनकेव मिरर इज ऑलवेज नेगेटिव। ठीक है, कॉनकेव मिरर केस में फोकल लेंथ जो होता है दैट इज ऑलवेज नेगेटिव, and the focal length of a convex mirror is always positive. The focal length of convex mirror is always positive. ये कुछ concepts है या फिर कुछ points है which you have to remember while solving the numerical problem. Now we have some numerical problem based on mirror formula and linear magnification. Okay, the very first question is find the size, nature, and position of the image formed when object size is 1 centimeter and distance from mirror is 15 सेंटीमीटर. ओके, हम लोगों ने यहाँ पे फाइंड क्या करना है, तीन चीजों को फाइंड करना है, नेचर, साइज एंड पोजीशन ऑफ द इमेज. सो द ऑब्जेक्ट हाइट इज 1 सेंटीमीटर. ऑब्जेक्ट की हाइट यहाँ पे हम लोगों ने देखा है, इट इज 1 सेंटीमीटर. ओके, एंड इट इज 15 सेंटीमीटर अवे फ्रॉम द 15 सेंटीमीटर अवे फ्रॉम द मिरर. मिरर से वो कितनी डिस्टेंस पे है, द डिस्टेंस इज 15 सेंटीमीटर. डिस्टेंस कितनी है, 15 सेंटीमीटर. ओके, अब हम लोगों ने यहाँ पे क्या देखना है, वी हैव टू फाइंड size, nature and position. Size, nature and position of the image formed. Okay, so the object distance is minus 15. क्यों? Because it is leftward distance. Left side distance है ना, अगर incident rays होती तो ये इस direction में होती and it is against the incident ray direction. ठीक है, तो ये negative होगा minus 15. We have to find the image distance and we have the focal length that is 10 centimeter. Focal length, it is the focus. ये जो यहाँ तक की distance है, it is 10 centimeter. Okay, it is the focus, it is center of curvature and it is 10 centimeter. अब यहाँ पे एक और क्वेश्चन हो सकता है कि मुझे कैसे पता चला कि ये इमेज जो है वो सेंटर ऑफ कर्वेचर और फोकस के बीच में होगा. डू यू रिमेम्बर द फॉर्मूला f is equal to r by 2 और r is equal to twice the focal length. ये फॉर्मूला इसके पिछले वीडियो में हम लोगों ने डिस्कस किया है, twice the focal length. ठीक है, तो फोकल लेंथ अगर मेरा 10 है, देन सेंटर ऑफ कर्वेचर और रेडियस ऑफ कर्वेचर वी रिप्रेजेंटेड बाय r आल्सो. सो ये ट्वाइस होना चाहिए, इट मींस इट मस्ट बी 10 प्लस 10 दैट इज 20. तो 20 नहीं है, यहाँ पे 15 सेंटीमीटर ऑब्जेक्ट की डिस्टेंस है. इट मींस इट विल लाई बिटवीन द सेंटर ऑफ कर्वेचर एंड प्रिंसिपल फोकस. ओके, now we will come to the point. Now putting these value means object distance and focal length, where we have to put this value in mirror formula. यहाँ पे हम लोगों ने देखा कि फोकल लेंथ इज नेगेटिव. व्हाई इट इज नेगेटिव, यहाँ पिछले पॉइंट में हम लोगों ने देखा था द फोकल लेंथ ऑफ द कॉन्केव मिरर इज ऑलवेज नेगेटिव. और ऐसे भी हम लोग देख सकते हैं, इट इज द लेफ्टवर्ड डिस्टेंस. पोल से हम लोग जो ये डिस्टेंस मेजर कर रहे हैं दैट इज लेफ्ट साइड. तो लेफ्ट साइड में होगा तो क्या होगा, ये इट इज नेगेटिव. Okay, now using the mirror formula, that is 1 by v plus 1 by u is equal to 1 by f. We will put all the values here and to find out the value of v, we will solve this addition. ठीक है, सब ये हम लोग सिंपल जो हमारा फ्रैक्शन का एडिशन होता है उसी तरह से इसे हम लोग सॉल्व करेंगे बाय टेकिंग एलसीएम ऑफ 10 एंड 15. ठीक है, 10 और 15 की एलसीएम लेंगे यहाँ पे, ये हो जाएगा मेरा 30 and we will do here minus 3 plus 2. So we will get 1 by v is equal to minus 1 by 30, that is v is equal to minus 30 centimeter. Minus sign indicates that the position of image is left of the mirror. Now the nature of image is, since the object is formed in the front of concave mirror, so its nature will be real and inverted. Nature कैसा होगा image का, real and inverted. Now to find out the size of the image, we will find the linear magnification of that image. Okay, linear magnification find out करने के लिए हम लोगों ने क्या पता करना है, image distance, that is we find out अभी अभी हम लोगों ने में से पाया that minus 30 centimeter and the object distance is minus 15 centimeter. According to the formula of linear magnification, we have minus v by u, that is minus into minus 30 divided by minus 15. This minus and this minus cancelled out. So the linear magnification will be minus 2. As I told you earlier that magnification does not have any unit. So we put this value अगेन वी हैव द फॉर्मूला HI/HO, ये भी तो लीनियर मैग्निफिकेशन का एक फॉर्मूला है. सो मैग्निफिकेशन हम लोगों को मिल गया and object distance we know that it is 1 centimeter. We find out the height of the image, that is minus 2 centimeter. So the size of the image is minus 2 centimeter, means minus sign indicates that the image is real and inverted. ऐसे 2 centimeter इसकी length होगी. Okay. The second question is, a concave mirror produces 3 times magnified real image of an object placed at 10 centimeter in front of it. ठीक है, एक concave mirror है जो 3 टाइम मैग्निफाइड इमेज को प्रोड्यूस कर रहा है अगर कोई ऑब्जेक्ट 10 सेंटीमीटर के डिस्टेंस पे रखा हुआ है तो. ओके, तो मैग्निफिकेशन विल बी -3 बिकॉज इट इज रियल एंड इन्वर्टेड इमेज. रियल इमेज बन रहा है तो मैग्निफिकेशन मेरा कैसा होगा, माइनस साइन में. ठीक है, सो मैग्निफिकेशन इज -3. ऑब्जेक्ट डिस्टेंस इज ऑलवेज नेगेटिव, so -10 centimeter. According to the formula, we have m is equal to -v by u, that is -3 equal to -v by -10. Okay, this minus and this minus again cancelled out. We multiply 10 by 3, that means v is equal to -30 centimeter. Thus the image is located at the distance of 30 centimeter in front of the mirror. Minus sign indicates that the image is in front of that mirror. The third question is, an object 5 centimeter high is placed at a distance of 10 centimeter from a concave mirror of radius of curvature is 30 centimeter. Radius of curvature हमारा कितना दिया हुआ है, that is 30 centimeter. We have to again find the nature, position and size of the image. So let us see the solution. Here object distance is -10 centimeter because we already know that object distance is always negative. We have to find the image distance, but here it is not given focal length. We have to find out the focal length by using this formula, f is equal to r by 2. So radius of curvature it is given 30 centimeter. So we will find out the focal length 30 by 2, that is plus 15 centimeter. If you remember, you know that the focal length of the convex mirror is positive. ठीक है, focal length convex mirror का जो होता है वो right side में होता है, that's why it is positive. Okay, so using mirror formula, again we will use the mirror formula and putting these values means u and f, we will find out the value of v. अब क्या करना है हम लोगों ने इसे यहाँ पे, u is -10, f is +15. So we will take this u this side, equal to के इस side ले आएंगे, then it will become +10. By taking LCM 15 and 10 we get 30 and we add 2 plus 3, that is 5. So 1 by v is equal to 5 by 30 means v is equal to +6 centimeter. ठीक है, the position of the image is 6 centimeter behind the concave mirror because convex mirror, because we see that convex mirror always forms virtual and erect image. Convex mirror कैसा image form करता है, it forms always virtual and erect image. Now we have to find out the nature and size of the image. So again we will use the formula of magnification. मैग्निफिकेशन के फॉर्मूले को यूज करके हम लोगों ने यहाँ पे निकालना है, m is equal to -v by u, v is +6 centimeter, u is -10 centimeter. Again what happens here, minus into +6 divided by -10, that is we get the magnification plus 0.6. By using this value, we put it again in this formula, m is equal to hi by ho. So we get the height of image +3 centimeter because it is virtual and erect image. So the size of image is +3 centimeter. यहाँ पे एक चीज हम लोगों ने और नोटिस करना है, that object height is given 5 centimeter and we get the image height 3 centimeter. It means it is, as it is a convex mirror, we get the height is smaller than the offset. In next video, we are going to deal with the topic refraction of light and all the basic concepts along with the image formation by lenses. So please do not miss the video. Thank you very much for watching.